we will have actually some example to understand these three conditions, and we will have examples just to learn how do we calculate these cutting and then filling. Okay, let's move ahead, and I'll just give solution to an example related to fully in cutting. Okay, if we have cutting such as this, what we have to do is just determine the area of the section, and then we will just multiply this area with the length. Now if this area is at both ends, okay, or you can say if this depth is just different for both ends, then we may use mean depth over here. Okay, and if you're doing this calculation for mean area, then we have to determine the mean area. Maybe let's say this is section at one end, okay, and there is, let's say, another section at another end. Then let's say this is A1 and over here this is A2. Then we of course have to determine the mean area is A1 plus A2, and then we will divide that by 2, and then we will actually multiply this with the length, so we can have the volume, or maybe the total volume in cutting, or maybe the earthwork in cutting. And these are actually the terminologies which we have already discussed, like maybe the cross slope, okay, of the ground, which is the slope of the natural ground, you can say. And then we have the side slopes, which is S/1, and then actually D means the depth of cutting at the center, okay, which is, as you can see, this is D in the same section. So we will have actually an example just to have the complete solution to the earthwork in cutting, okay, maybe in fully in cutting. So we have this example, very simple example, okay, and as you can see, we are asked to work out the quantity of earthwork for 50 meters long road. Okay, the road length, that is actually 50 meters, but this is actually in hilly area. Now the formation width of the road is 10 meters, that is known. The average depth for cutting, it means this is just the mean depth. Okay, so this is given is average video. Okay, so in average depth for cutting at center, that is actually 2 meters. Now the cross slope of hillside is 10/1 and side slope is 1:1 in cutting, and then actually there is 1.5/1 in filling. Okay, if we have filling, actually the section, or maybe the diagram may look like this guy, as you can see. So this data, okay, I'm going to replace this with another diagram, but before, as you can see, we have some given data, and over here we have the breadth of the road, which is 10 meters. Now this breadth is actually the capital B, okay, in the same diagram, and what we need actually is the small breadth, okay, maybe up to the middle portion, or maybe up to the depth which is taken at mid section. Okay, so this is going to be just B by 2. It's very simple. And then we have actually half width, so it can be 5, because 10 divided by 2, that's going to be 5. And then the mean depth, which is 2, and this is actually the same thing is this depth. Okay, this is 2 meters. And then we have actually the cross slope 10/1, and that is actually the R/1. And then we have the side slope, which is 1:1, and then the length of the road, and that's of course 50 meters. Okay, and the solution, as you can see, the earthwork, or maybe the volume of earthwork, can be area in cutting, which is actually this area, the red shaded area, you can see that. So we have to determine this area, and then we will multiply this area with length. Okay, so we can have the earthwork. That's going to be very simple. Okay, and if you remember, for the same section, or maybe if the section is just in cutting, we can use that previous formula. Very simple. Okay, SB square plus 2R square BD plus SR square B square divided by R square minus S square. Very simple. So what we have to do is just to have some plug and check in the same formula. Okay, and then we will have some mathematics, so we can have area and cutting. Area and cutting, as you can see, we have SB square. Okay, and you can even just look for this formula in the same reference. Okay, which is actually not needed in the same section, however, no problem. Okay, so putting some values like S, which is going to be 1, that's known, which is side slope. Okay, you can see that, times B square. B is also known, as you can see, that is 5, which is just half of the formation weight, you can say. So 5 square plus 2 times R square, R is also known, which is 10. You can see that. So 10 square. And B, again, that is known 5. And D, which is also known, and that's, of course, 2 units. Plus, again, R square. Okay. S times R square. Sorry, that's S, which is, of course, 1. R is, again, 10 square. And D, that is known, which is 2. So 2 square. And divided by R, which is actually 10 square minus S, and that's going to be 1 square. Pretty cool. Very simple. Do some maths, okay, using maybe your calculator, and you must have area, which is 24.50 square meters. Now, we will multiply this area with the length to have the earthwork, okay? So area 24.5 times the length, and that is 50. If you see that, okay, it's just given in the example terms. That is just 50, okay? So multiplying these two, we can have actually the quantity, and that's 1222 cubic meter, you can say. Very simple. It means that the final result we have is 1225 cubic meter is the earthwork, which is actually this shaded area. This is actually going to be the earthwork for the same cutting. Just moving ahead, and we will have another example for the filling. Okay, if we have a section